Hello, everyone, and welcome. Today, we're going to talk about something that's literally right under our feet, but, we probably don't think about it very much. We're going on a little adventure into the amazing world of rocks and minerals. Have you ever just been walking and you look down and wonder, what is the ground really made of? Or what story could all those little stones and pebbles on the road tell us? Well, that's exactly what we're going to explore today. So let's start with the most basic question of all. We see rocks everywhere, right? From huge mountains to the tiny pebbles in a park. But what is a rock, really? A rock, in simple terms, is a hard, solid thing made of mineral matter. Now, the main thing to remember is that it's not just one single substance. It's usually a mixture of two or more special rock-forming minerals. You can think of it like a laddu. The rock is the whole laddu, and all the different ingredients like the flour, the sugar, the nuts, those are the minerals that make it up. Now, this is where it gets really interesting. Not all rocks are the same. You can think of them as having three main families. And believe me, each family has a completely different story about how it was born. So, first up, we have igneous rocks. The name itself, igneous, comes from a Latin word, ignis, which actually means fire. And that's a perfect name for them because these rocks are born from very, very hot, melted rock called magma that's found deep, deep inside the earth. Okay, so how does this hot magma turn into a solid rock? Well, there are two ways. If the magma cools down very slowly, deep under the Earth's surface, it forms what we call intrusive rocks. It's kind of like a cake baking slowly inside an oven. But if the magma erupts onto the surface, maybe from a volcano, it cools down very, very fast. This forms extrusive rocks. That's more like taking the cake batter and putting it in the freezer to cool quickly. Our second rock family is the sedimentary rocks. Again, the name gives us a big clue. It comes from a Latin word that means settling, and that's exactly what these are. They are rocks made from tiny little pieces of other rocks, or sometimes even shells and sand, that have settled down in one place over a very, very long time. This is a long, slow process. It's a real journey for these little rock pieces. First, big rocks get broken down by things like wind and rain. This step is called weathering. Then, these little pieces are carried away by rivers or wind. That's transportation. After a while, they settle down somewhere new, maybe at the bottom of a lake. We call this deposition. And then the final step, diagenesis, is where all those settled layers get squeezed and glued together to become a brand new rock. So you see, it's a long story of breaking down, traveling, settling down, and then finally coming together again. And now for our final family, the metamorphic rocks. The name itself tells the whole story. Meta means change, and morph means form. So, simply put, these are rocks that have completely changed their form. So how do they change? Well, imagine an older igneous or sedimentary rock getting buried deep inside the earth. Down there, it gets cooked by intense heat and squeezed by a lot of pressure. Sometimes hot water is also involved. This whole combination of heat and pressure, it acts like a giant oven, baking the original rock until it becomes something totally new. It doesn't melt completely, it just transforms. So those are the three big rock families. But remember our laddu example? A rock is the laddu. But what about the ingredients? What are the actual building blocks that make up all these different types of rocks? Well, those building blocks, those ingredients, are called minerals. Just think of them as the pure, basic materials that are mixed and matched in different ways to create all the rocks we see in the world. So a mineral is something that occurs naturally. That means it's not man-made. The most important thing is that each mineral has its own special chemical recipe and a very specific crystal shape. Think about common table salt. Salt is actually the mineral halite, and if you look very closely, its tiny crystals are always perfect little cubes. That's its characteristic geometric form. Now, with so many different minerals out there, how do geologists, the scientists who study rocks, tell them apart? Well, they have to become like detectives looking for special clues. And these clues are what we call the properties of the mineral. The first and most obvious clue, of course, is color. For example, the mineral magnetite is always black. But we have to be a little bit careful. Just like two different types of flowers can both be red, different minerals can sometimes have the exact same color. So, color is a good starting clue, but it's not always the most reliable one. A much better clue is hardness. This is basically how well a mineral can resist being scratched. Geologists use a special scale for this called the Mohs scale. It goes from 1 to 10. At number 1, we have the softest mineral, which is talc. You find it in talcum powder. And at number 10, we have the hardest known mineral. Can anyone guess? Yes, that's right, it's diamond. Another very clever clue is something called streak. Now, this is not the color of the whole mineral, but the color of its powder. To find it, you scrape the mineral on a rough surface. And what's really useful is that sometimes a mineral's streak is a totally different color from its surface. This makes it a very, very good clue for our geologist detectives. Our next clue is called cleavage, and it's all about how a mineral breaks. Does it just crumble into random bits, or does it split cleanly? Some minerals, like diamond, tend to split along perfectly flat surfaces. You can think of how a piece of wood splits neatly along its grain. It's a little bit like that. This property is actually what helps gem cutters create those beautiful shapes. Okay, so we've learned all about the rock families and the minerals that build them. But this brings us to the biggest question of all. Why should we care? I mean, why do rocks and minerals actually matter in our everyday lives? Well, it turns out they matter more than you can even imagine. Just look around you. The soil that we use to grow all our food, that comes from broken down rock. Many resources we need every day, like coal for energy, are actually types of sedimentary rocks. And the very buildings we live in, the salt we put in our food, all of this comes from rocks and minerals. They are, quite literally, the foundation of our entire world. So, the next time you're out for a walk and you see a simple stone and pick it up, take a closer look. Will you see just a boring old rock? Or will you now see a story of fire? A story of a long, long journey across rivers and winds? Or a story of a deep change under great heat and pressure? What story will you see in it